Okay, this is a chapter 2 review. Hopefully this comes off. Okay, we're going to start the test with a conjecture. You remember what a conjecture is? Statement that from something. So if I do 4, 16, 64. Tell me what the next number is, and then what's the conjecture? Is it 256? Do you agree?
Yeah.
So it's 256, and then what is the conjecture?
Multiply each term by 4.
Okay, multiply each term by what? I think it's by 4, isn't it?
16 times 16.
Yeah. Okay. All right. So then you know how to do a conjecture. Okay. Any questions about a conjecture? Okay. And then conjectures can be true or false. Okay. So if I say, let's see if I can find one. I don't know if there are any in here. If x is a positive integer and y is a negative integer, then x plus y is a negative integer. True or false?
False.
False. You want to give me a counter example, please?
Y can be greater than X.
Okay, so give me an example.
Okay, so, 6 plus a negative 3.
Okay, very good. 6 plus a negative 3 is 3. That is a counter example. You have a couple of those. Okay? All right? Okay, then we talked about conjunction. And disjunction. Remember that? A conjunction is what? What word do we use? What's that? And the disjunction is or. Okay. All right, so let's say that we have P is x squared is a non-negative.
Please excuse the interruption. Teachers, would you dismiss the junior high wrestlers who are going today at this time, please? Thank you.
X squared is a non-negative number. Q is adjacent angles lie in the same plane. And then R is a negative number is not a real number. Now, let's be clear here. Is the first one true? P? Is P true?
Yes.
Yes. Is Q true? It is. Okay. Adjacent angles must lie in the same plane. But is R true? No. No, R is not true, right? Okay, so what I want you to do is, I'll just choose one, 3. Let's go, what is that symbol?
Opposite.
Opposite? It's
Not.
It's a not, right? It's a not. Okay, so how do I write this?
Not Q and, not adjacent angles lie in the same plane, and the negative number is not a real number.
Okay, so you can't just say not adjacent angles. Okay, that's not very good English, right?
No.
So what do I say? Adjacent
Angles do not
do not
lie
lie in the same plane. Is this an and or an or? This is an and. And she said a negative number is not a real number. Is that true? Okay. I mean, did I write it right? Is what I meant. Okay. So, what do you think?
False.
This is false. Why?
Because
for the hypothesis.
What did you say, Jenny? They're both false. They're both false, aren't they? So it's not true. Okay, do you want to do another one of those?
Yes.
All right. Let's do this one. Okay. True or false?
true.
Okay, let's take a look at P. P is true, right?
Mm-hmm.
So right there we can stop, can't we?
Yep.
Okay, so this is true, isn't it? You'll still have to write it out. So can somebody read it to me, how they wrote it out?
X
X squared is a non-negative number, or a negative number is not a real number.
Very good. X squared is a non-negative number or a negative number is not a real number. Okay? Do we have these notes? Okay. Tyra, you gotta be a little louder on that because I can't hear very well. I just about erased it.
Okay, keep going.
All right. Ready? Okay, so the next one we're going to do the converse, the inverse, the contrapositive, and all that jazz. Remember that? All right, so I'm going to give you a statement. All right? I'm going to give you a statement. And it says a square is a parallelogram. Oops, spelled parallelogram. Okay. All right, now the first thing I want you to do, what number am I on?
Number 3.
3. I want you,
5. No,
5.
5. Sorry.
Okay, we're just making numbers up now. Okay, what I want you to do, I want a conditional. What's a conditional? It's an if-then. Okay, so write this as an if-then for me. Kagan? If a what? Okay, let's put if a figure. How's that? That's a little better English.
Is a square, then it is a parallelogram.
All right. The figure is a square, then it is a parallelogram. Okay, so would you tell me, Angel, what is the hypothesis?
A figure is a square. A figure is a square.
A figure is a square. No if, right? And then what is the conclusion, Connor? It is a parallelogram. Does everybody understand that?
Yeah.
Okay. So now, number 6, Dylan, you're going to give me the converse. Okay. Oh, by the way, was the conditional true or false? It was true. Okay, so Dylan, you're going to give me converse. Chinny, you're going to give me the inverse. And then Aubrey, you're gonna give me the contrapositive. Okay, so what is the converse there, Dylan?
If a figure is a parallelogram, then it is a square.
If a figure is a, can I use a symbol? This is a symbol for parallelogram. Then it is a square. Now I want you to write it out tomorrow, but I'm kinda, for time's sake, I wanna make sure we get through everything. I think we'll be alright. If a figure is a parallelogram, then it is a square. Is that true or false, Dylan?
True.
Is that a square?
No.
So if a figure is this, then it is a square. Is that a square?
No, it's not a square.
So then this is false. Okay. Okay, you got that?
Yeah.
Okay, who's up for inverse?
Me.
So, Chin,
If a figure is not a square, then it is not a parallelogram.
the figure is not a square, then it is not a parallelogram. Correct? And is this a true or false? False. Okay. Now, without even thinking about it, if the inverse is, if the converse is false, then the inverse has to be false too, doesn't it? Okay. All right. And then the contrapositive there, crazy woman.
If a figure is not a parallelogram, then it is not a square.
Okay, is not. Okay, once again, I'm gonna use this symbol. Then it is not a square. Okay, and is that true or false, Aubrey?
True.
Okay, true. And it has the same as the original conditional, right? It has the same truth value, right? Okay. All right. So, can you write a biconditional from this?
No.
No.
Okay. All right. And why?
Because you only have one statement, right? For one condition. Because don't you need two conditionals?
No, I mean your answer's right, Angel.
Isn't it because the converse and conditional are the same? Or is it both?
It's because the conditional and the converse do not have the same. They're not both false, or they're both not both true. Okay, so if they were both true, I could do that. For example, if I said, if today is Thursday, tomorrow is Friday, right? The converse of that is if tomorrow is Friday, then today is Thursday, right? And so, maybe I should write that down. Do I need to write this down?
Yeah, sure.
Okay, this one we just can't write the biconditional. But if I say, if today is, if today is Friday, no, today's Thursday, Mr. Ellis. If today is Thursday, then tomorrow is Friday, right? That's a true statement, correct? Can I get an amen, something? Some heavy breathing, thank you. All right, so if tomorrow is Friday, then today is Thursday, right? Correct? Both of those are true, correct? So, Tyra, can you write a biconditional given that information? You start with this word, underline.
Today is Thursday. And
If
tomorrow is Friday.
If and only
and
if.
only if.
Tomorrow is Friday. Does everybody understand that? Yes, no, maybe?
Yeah.
Okay, and you gotta get something from me, alright? Alright. Any questions then? Alright, Maurice,
Can you wait a second?
yes I can, thank you. Thank you. All right, so the next thing we're gonna talk about is deductive. Oops. Deductive. No, I'm sorry. Yeah, and inductive reasoning. Okay, so deductive, there has to be a rule, right? All right. So if I say, what number is this? 9. Well, let me just give you an example. Let me give you examples, and you tell me what it is. Okay. Usually every Monday, Mr. Keeney has 3 cups of coffee. Today is Monday, so Mr. Keeney has had 3 cups of coffee. And if you throw some, I think I've used this before, but if you throw something in this class, you have to stay in, right? My writing's not very good. Stay in. Tom drew a pencil. Oops. Tom threw a pencil and asked to stay in. Okay. All right, what's the first one? Inductive. There's no rule that says that Mr. Keeney has to have 3 cups of coffee on a Monday, is there? Okay. What about the second one? Deductive reasoning. All right. That is a rule, right? Okay. Now, then we talked about law of syllogism and law of detachment, right? Do you remember these? Okay. Let's try one. Let's try this one. Maybe I better put them up here at the top. Law of detachment and versus law of syllogism, right? They might need some help spelling this one. Okay, now I have them in the directions, so, right? And you might have to make a conclusion too, right? So let's take a look at this one. This is number 11, correct? So, if a quadrilateral has diagonals that bisect each other, then it is parallelogram. Okay? Then it says the diagonals and I'm going to abbreviate quadrilateral. I'm just going to put quad. PQRS. PQRS bisect each other. Can you make a conclusion? Anybody? What is?
PQRS is a parallelogram.
Okay, so PQRS is a parallelogram, isn't it? And what's the reasoning?
Because if the parallelogram has
No.
diagonals that bisect each other.
Okay, which one is it? Law of detachment or law?
Attachment.
This is a law of detachment. Okay? Anybody come up with a, well, let me just try this instead of. If the measure of an angle is greater than 90, then it is an obtuse angle. If an angle is an obtuse angle, then it is not a right angle. All right? Can anybody make a conclusion then? And tell me which law this is?
If the measure of an angle is greater than 90, then it is not a right angle.
Okay, so if a measure of angle is not greater than 90, then it is not a right angle. You'll have to write all that out. And what law is that? Law of syllogism. Okay? How are we doing so far? Good? Okay. Okay, so then you remember we talked about angles, right? And segments and what their length was. Remember that? So, we have a segment like this, and we call it, we say this is A, this is B, and this is C. And we know that this is 2y plus 18. I'm going to try to make this up without messing it up. These are hard to do because you get into negative numbers. And this is 3y plus 20. And the whole thing is 12y minus I don't know, 10. I don't think they're going to get it.
Is that 18 at the top?
Yeah, 2y plus 18. Okay, I don't know if that's any better. So how would I set this up, Connor, to solve for y?
2y plus 18 plus 3y plus 20 equals 12y squared.
Okay, and I don't know that this comes out right. When I say I want y to, it's probably not gonna come out right, but 5y plus 38 equals 12y minus 10. If we subtract from both sides, we get 7y, and I bring the 10 over here, equals 48, and so y equals 48 divided by 7, okay? And then you might have to find the lengths of the values. You'll have to do that with angles, and you'll have to do it with segments, okay? The angle one is a little bit more complicated. Remember that section? I'm not sure what section that is. We did worksheets on it, right? 1-6. Remember worksheet 1-6? okay? You'll have to do that. So I give you an example one, you'll have to do one for angles also, okay? So what number would this have been? 13. Okay. Now the next part says write an equation in slope-intercept form that, bing bing, 14, passes through points 3 and negative 2 and a negative 5 and negative 4. Okay? And what would I do first, Tyra? Okay, anybody? I'm gonna have to move on. We're on a kind of a time constraint.
Subtract the rise.
Okay,
over
so,
the x.
alright, well, I gotta find the slope first, right?
Yeah.
Which is rise over run, so I gotta take negative 2 minus negative 4 over 3 minus negative 5, correct?
Yes.
Make sure you do that wise, so this would be positive 2 over 8,
Yes.
it's 1/4. And so then I go, what's that, y minus, it doesn't matter which point I use, I'm gonna use the first one. Y minus negative 2 equals 1/4 times x minus 3, is that correct?
Yes.
So I have y plus 2 equals 1/4 x plus a negative 3/4, correct?
Mhm.
And now I'm gonna subtract 2 from both sides. Y equals 1/4 x. Negative 2 is a negative 8 over 4. So negative 3 plus negative 8 is a negative 11 over 4. That line right there passes through those 2 points. Correct?
Mhm.
Okay, so what number am I in? 15. Right in slope intercept form a line that passes through three, negative 2, and is perpendicular to x plus 2y equals 6. Dylan, how do I begin?
I would make x plus 2y equals 6, I'd put that into slope intercept form.
All right. So that would be, to do it quickly,
It'd be y plus negative 1/2 x plus 3.
Y equals
negative 1/2 x plus 3.
plus, I think she's correct. So then if that is your slope, what's the slope of the line you want?
It'd be opposite.
It'd be 2.
2. So then we go y minus a negative 2. What if it's parallel?
It'd be a
It's the
negative
same.
one.
It'd be a negative 1/2. So we go y minus negative 2 equals 2 times x minus 3, correct? And so we get y plus a 2x minus 6. And we subtract 2, then we do subtract 2, which is plus a negative, right? So I'm getting y equals 2x plus a negative 8. Is that right?
Yes.
Okay. Okay, I'm going to give you a picture over here. You can call this A, this B, this C, and this D. Everybody see that all right? I'm going to label these as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. I'm going to give you a pair of angles and something that's going on with them, and you're going to tell me what two lines are parallel, given the information, and then you're going to tell me what postulate or theorem supports your cause. Alright, so I'm going to go angle 1 is congruent to angle 14. What two lines are parallel? Chin.
A and B,
A is parallel to B. What reasoning?
alternate exterior, no, converse of alternate exterior theorem.
Converse of alternate exterior angles theorem. Please only abbreviate angles and theorem, please.
So if you're proving that a line is parallel, you just put converse and then whatever it is, like that's a
Yep.
alternate interior, and then
Yep.
put theorem on the end,
Yes.
always.
I'm not gonna say always because that always gets me in trouble. So, but on these, this is what we're looking for. All right, so now we got the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. What two lines are parallel? Angel.
Three.
C and D.
C is parallel to D, correct? And what would that be, Angel?
The. Oh, yeah, it's the
Converse?
Converse.
If you help her, Ginny, then she can't do it on the test. And I don't want you helping her on the test because then you'll both get zeros.
Is that supplementary?
Same, it's consecutive.
I like same side interior angles, but I will accept both. Now you can't just make up stuff. Okay? Converse of the same side interior angles theorem. Okay? Alright. Then the last couple, oh, by the way, you are not to do number 22. Don't do number 22 on the test. I'll try to remind you before the test. Okay? Do not do which number? 22. Alright. The last couple questions are always, sometimes, never questions. So you got a 33 1/3% chance of getting them right. What number am I on? 18. Two planes intersect add a point.
Sometimes?
Never. They intersect at a line.
Oh.
2 planes from the line.
Same side interior angles are supplementary.
True. Solid.
I have not heard one answer. I hear mumbling. Sometimes. Do you agree?
Yes.
Sometimes. Tell me about that. If the lines are parallel, then they are. If not, they're not. Okay? 20, the last one. If two angles are complementary, then they form a right angle.
Always.
Always. He says. You agree? Mm. Say this is 40 degrees and this is 50 degrees. Do they form a right angle? No. Why not? They're not adjacent. So sometimes they have to be adjacent. That's a tricky one, won't it? That'll make your blood curl, won't it? Alright.
How many questions are
There are 24, 23 without 22, right? And the points are 35. Okay? Alright.